the Seika has access to audio, if you just highlight any questions that might come up while I run through. So morning, evening, everyone. My name is Oliver Ben. So I'm from the Oxford IBM side of the KDD Cup, and in addition to the previous Q&A we'd done, and based on the requests for some more baseline solutions and ideas solving the problems, I wanted to take the time today to walk through some different simple tutorial code that hopefully again serves as illustration and an update to how you might want to package your code, go about developing your submission, and again produce valid submission files to go into the platform leaderboard. With the view now that we're in the final month of the initial phase, and we'll be taking submissions from the leaderboard and passing them through to the next stage submission, where there will be a change in the environment, still the same observable states, so nothing should change from the submission file, but there will, the nature of the rewards returned from the environment would be different, as it describes a different malaria endemic location. So let me proceed with just the introduction to the framing of the moment. Just a simple transition from 5 years of interventions. At each intervention year, an action of two values between 0 and 1 can be taken. Physically, these describe distribution of bed nets, ITN, and indoor residual spraying interventions, but you could think of them simply on a continuous range between 0 and 1. And by posting these actions to the environment, the user is able to receive stochastic rewards at each state or year transition in a stepwise fashion. It's also possible to query the episodic reward for the full sequence once that's been generated as well. So we'll go through, I believe, 2 methods of generating that reward. So just housekeeping here. I guess really the only sort of mandatory inputs are from the challenge API. Just make sure, if compared to there have been other versions of people looking around for within the repository, is really the challenge folder, the import and APIs will work for your submission. So these 2 lines should run everything for you. There are some other imports this code is going to use. So, and I guess it goes without needing to highlight too clearly, but an internet connection would be needed to run your submissions. So, the goal here is we're going to use one method of action selection, so picking a combination of interventions on the range of 0 to 1. These 2 interventions of bed nets and spraying, in order to learn a value function, and given you really to replicate the process that you might want to take, just a tutorial that goes into a lot of the backgrounds of the mathematics of behind the Bellman and update equation, how that's posed in the Q learning paradigm, and the background and theoretical framing for that from a blog post reference here. So I would strongly recommend for deep understanding of what's going on, referring to other material. really the purpose here is just to give you some confidence and understand that you can look at both standard techniques, but perhaps implement your own on top of those, and just see how that still fits within the scope of the challenge. So yeah, please, perhaps while you're watching this, I can just point you to the tutorial section on the platform. In this case, I've just gone straight through to the policy gradients tutorial, which I'll go through later. That probably. Otherwise, there's last Q&A video that I've gone through to here. But from the homepage, rather than me trying to skip through, if you pick the tutorials, just to be clear, I'm following a notebook version of this outlined. So yeah, if you want to click through to that blog post, and while I'm talking, maybe try and link some of the ideas, or later look through it. That's your reference point. So yeah, back to the notebook. Yeah, we're again going to initialize our sequential decision-making environment and generate a dictionary of key values and visits of states. These are going to be updated at runtime based on the key value update equation. So what's happening here is defining some action space. So this is a tabular Q-learning solution. So there's no network which is learning any distribution across possible actions. We're taking a discretized action space from the 0-1 space of bed nets and spraying. So picking or almost picking 2D actions across this tabular space or discretized space now. So this is just implemented in this method with particular resolution steps across the 0-1 space, and you can see picking here 0.2 as these steps. So quite a granular resolution in the submission, and maybe this would be something that participants might want to play around with these hyperparameters when running code to see if that improves at least the submission for this approach. Great. So given this action resolution and a slightly smaller episode number, actually this would be fixed at 20 for the submission, but we're just going to run test runs on this. Epsilon describes this notion of E-greedy that we have for Q-learning. So in 0.1 proportion of instances, we're going to perform an action that is exploratory. So actually 1 minus 0.1 would be the exploratory action. And what I mean by difference between exploration and exploitation is that in exploitation, we're going to perform the action that we believe maximizes our cumulative reward, or at least the reward from the next step that we can achieve. So this is entirely based on information that we've already collected, and we're going to make the decision which best maximizes our current knowledge. And in exploration, well, there are multiple mechanisms of that, but essentially we'll perform an action which can be randomly selected in order to better understand the available actions and perhaps explore complete policies which may be higher performing. So that's a particular hyperparameter here, as well as our discount factor gamma, which discounts future rewards. Again, these are simply offered as a standard implementation and hyperparameters that can be tuned by participants. Perhaps it's not needed, but the notion is that we want to more heavily weight current rewards received by the agents, believing that anything received right now is a slightly higher value than what we might receive in the future. Okay, so we have our action space at a defined resolution. This is split up into a numerical set of actions and defining what. Now, this is quite complicated. Well, more advanced Python code here with the lambda functions. I'll just give a high level. Without spending too much time, essentially we're still storing the Q values for the greedy action and the maximized value of those Q values. So if we run over 3 episodes, as we said before, we'll reset the state, have our state transition moving across the years, and when our with some probabilistic choice, when our value of 0.1 epsilon is greater than some random selection between 0 or 1, we'll take a random action from us space. Otherwise, we'll take the greedy action, which corresponds to what we've learned in our tabular Q learning fashion, and perform this action on the environment, evaluate receiving rewards and transitioning to the next state. And these are the Q value update equations here. So if I run through what's described there, in addition to after performing on these episodes, what we're going to do is take our table of Q values and evaluate a best policy across the state transition. So we've learned a table of Q values, and what we're going to do is, given the state, what is the greedy action for that state? We'll print out that best policy learned from the episodes of training.
If I may quickly just add, again, there is some list comprehension or dictionary comprehension in that example, on that line. In terms of defining the best policy. But as Oliver said, it is simply the question of, for a given state, what's the best action according to the Q table. That's all that line is doing. So you can implement that, and you could have implemented that in many other ways.
Thanks, Sekou. Yeah. I'm relying on any clarifications from Sekou here, and any questions that you might want to type through in case you're not able to speak directly. But equally, I don't want to spend too much time going through this. It's just nice to introduce the baseline and give you some confidence in developing further, though I'm sure there are several people listening who already have much better solutions than this and perhaps have other questions of their own. But as you can see, there are 105 evaluations on the environment, which essentially allows, across those 3 episodes, gives 90 left. So 5 states in 3 episodes. This kind of linear transition across the 5 years means that 15 evaluations are used up, and then there's an additional evaluation used in evaluating this entire policy. So this is what we're printing out here is the greedy policy extracted from the Q values learned and a reward associated with that policy. So yeah, and 2 out of the 15 actions were taken randomly. Otherwise, the initialized queue table is really guiding what actions are being taken, or just being printed out here. So that, I mean, again, the reason we've gone through this is kind of maybe this is how you want to play around with your code, see what's happening. And I'm just going to fit what was done here into the submission sample for the website. Yeah, for the platform itself. So you could imagine going through and playing with this section of code and tuning your hyperparameters and seeing what gives you better results. So creating a valid submission file from this agent code. Really, this is going to be contained within your queue agent class. And there are features within that class so that we can essentially call the environment your agent class and some submission file which you'll submit. So within your agent class, you'll initialize some values. Again, here your hyperparameters that stay fixed, your dictionary of queue values and states visited, which work in your queue value updates, and here definition of the actions and the size of your action space based on this resolution. So just calling this method here. So this generate method for your agent class is split up into a training step. So perhaps pay particular attention here, given that each environment has a limited number of evaluations, 105 as we were looking before. This gives you 20 episodes of length 5 to train your agent, and one sort of greedy evaluation from what you've learned. So this split can be performed in any way you like for your submission, but there are a fixed number of evaluations. For this particular method, it makes sense to learn your queue table over the 20 episodes and then take one more episode, 5 evaluations, to determine your best policy. So this is the same line that Seiko pointed to before, using up those final 5 evaluations. And within the training code, training method, we're simply doing what I stepped through before to generate the queue table. And so yeah, we've now gone from kind of prototyping what we wanted to do to split it in our agent class between some parameters that we start with the agent, methods that may define a discrete action space in this case. So this is custom to this particular method. We've decided to choose a discrete space across 0 to 1 actions, spend 20 episodes, and there's a do not change comment there, but this is common in the submission examples and used for the training and then a final evaluation. So this best reward is using evaluate policy, where we've learned a complete policy as a sequence of 5 actions, but at runtime and the stepwise rewards, we're taking the evaluate action method on the chosen action.
So also, if I can just jump in here, related to one of the QA questions that was typed, that evaluate policy, if you were using the multi-arm bandit framing, that basically, you would not use the evaluate action. Evaluate action treats it as you're trying to act on a on an MVP-like environment. If you just wanted to directly do one-shot policy loading, you could just directly use the evaluate policy. And I think when Ali talks about the next tutorial, I think he may go into that a little bit.
Yeah, exactly. So we wanted to give immediate flexibility to people, as well as speeding up the amount of code you have in the final evaluation of your policy. You can still take a bandaged approach to this, where your policy is essentially now this sequence of actions as one lever pool that you may want to learn also, rather than learning in the sequential sense. And as Seiko says, you can use both methods in how you want to implement what you're doing. Perhaps, so I can run this guy. So run my agent class. What the evaluate challenge submission method is now going to do for you is perform this, as you can see, the 10 times needed to generate your submission file. So our first run of doing that developed these results here, and this is going to be passed into your submission CSV. We can probably leave that running. On that point, Seiko, do you want to move to actually your GA code on the evaluate policy method?
Yeah, sure. So this is an example of a really rudimentary evolutionary-based method, so population-based search genetic algorithm. Most of the infrastructure should look exactly the same as the Q-learning setup. So you do have to do your installs of your Nets API so you can get the challenge API. There are some imports that are being done just to allow this particular submission code to work. I created a class shamelessly named RemiGA because I couldn't think of anything better. And this class will be used in the agent submission. For those of you familiar with genetic algorithms, the concept is that you are doing a population-based search and you evaluate an entire policy in this case, and based on the populations of policies that are evaluated, you would more likely select the better policies to determine the genetic material of the future populations. So that first cell is basically all setting up these concepts that define that are used to define how the GA works. But we can jump down. You have access to this, so you can take a look at this in all the gory details. It's really long, but if you go to the tutorials tab again, much the same as but the point is that this for the submission phase, this all needs to be self-contained. So this is why you have this entire piece of code here. You should not be doing a pip install of anything so that this can run. So when you submit your code, you need to basically make sure that all of the dependencies that are needed are there. We will cover dependencies like NumPy, SciPy. I think we're actually also including TensorFlow, right?
Mm-hmm.
Right. But if there are any other things, any other code that you have written, make sure that you're including it in your submission file. All right, so if you jump down to the next, the agent itself. All right, so in this concept, again, just as was done in Oliver's previous example, there's an initialization of the agent. In that initialization, I am instantiating the RemiGA object. For me, I'm using it as a solver. I do have a state space. My state space looks a little bit different. So again, in this case, the policy is basically, the entire policy is what's used for me. So if we scroll down a bit, when I'm training, since I'm doing a population-based search, I have a batch size of some kind. And in my case, the batch size is the population. So we have a certain number of samples total, but I only want to do the learning or the training in groups of pop size. So in this case, I think population size may have been set to 4 or 5 or something like that. But this is a way how you can implement a batch approach, even though you have a fixed number of evaluations. And this is the same, again, just a different solution to the same question. Here we are using the evaluate policy method, and we never ever use the evaluate action method because that's just not how this approach is set up. So this is similar to the multi-arm bandit framing. And then everything else should look the same. So for my generate method, I train, and then I use my version of the best policy line that Oliver had previously. And mine looks a little bit different because my actions are different. All right, so this is a really Pythonic way of generating all possible actions given the space of potential actions. You can take a look at it and tell me how you could have done it more efficiently, and I look forward to learning from you. So let's see if we can compare. Did my method perform better than Oliver's? Just for the tutorial.
I guess there's one observation when running this, that yeah, the associated compute of running an entire policy is slightly faster. Just we'll leave that with people on the Q&A as an observation.
Okay, cool.
Great. So this is your final score, right?
Yes.
162. I think you all have done significantly better than the not so intelligent QA code, but the Q learning code. Yeah, so 2x improvement on what was able to learn from this particular submission here.
Okay. Maybe I should put in all the bells and whistles. Okay, just kidding.
It's like, well, yeah. So with both examples, there's a chance to go through, try and play around with some of the hyperparameters if you want, just to understand the methods, get some thoughts flowing as to how you might want to better solve the solutions. And I'm not looking at the questions now, but certainly a common theme is just for this challenge in particular is well, the numbers of evaluations you're able to perform on the environment are really scaled back. Your participants are having access to really 100 times less what you would expect, and perhaps more on a standard reinforcement learning problem. And I just want to keep coming back to this is a reinforcement learning framing of the problem. We see advances in RL, and there's a lot of material for participants to draw on, but for this particular challenge and this problem domain, trying to apply these techniques even to learning from simulation requires a large amount of data efficiency. All of the evaluations that you're running require significant compute to return results, and I think learned is being evaluated on very few evaluations, and this should be bear in mind by participants, and everything that's worked on should hopefully be cognizant of that as you see relatively poor performance from tabular Q learning. I would, if there's an appetite to move on to the final tutorial, we can do, but also network-based approaches, you would want to think about what you're able to usefully learn over such limited evaluations in a not such a large network.
So some questions that are coming in via the QA, typed QA. So what's different between this phase and the upcoming phases?
Yeah, so as I said at the start, there'll be a new environment in the sense that the environment describes a different malaria endemic location. So, I mean, this perturbation is simply to avoid getting too good at a single environment, where we expect participants to generate solutions which generally perform well within the problem scope, but are not regressing towards some better solution within a single environment. So there's no change in the formulation in the sense that the same code should run exactly the same way on the new environment, but you're not learning a particular representation just for this environment you've had access to. I don't know if that covers.
Framing that a little bit differently, the point is your algorithms are really supposed to learn from the simulation data. Instead of, basically it's possible to overfit, yes. Hopefully your algorithms can compensate for that possibility. The other element is that, think of it like this. These environments are based on real locations. So things like maybe geography may be different, and maybe weather or temperature may be different. Accordingly, what happens with mosquitoes may be different. So one solution for, let's say, someplace in Kenya may be really different from a solution for somewhere in Thailand, right? So your algorithms are learning from the evidence presented to generate, in essence, what it thinks is the best policy. So that's the difference between these environments. So there's one question, and I guess I can read it without giving too information. If you start with an initial good policy and the policy does not change during learning, what would that mean?
So as you've seen in all examples, we've really initialized with some random policy or zero policy. If you are able to find good policies and maybe want to initialize your solutions around that, that would be kind of prior knowledge in your code, and something that during evaluation of the submissions in later stages would be flagged and picked up. So if fortuitously there's some random policy that is good that you choose to initialize around, that's great. But each submission file is generated across 10 runs. And I mean, this would come out in the stochasticity. So you would find your final score might not be weighted towards a single good initialization. Do you have anything to add on that, Sigurd?
Yeah, I mean, so one of the things, when you look at the leaderboard today, there are some submissions, especially at the top of the leaderboard, that are really high scoring. My guess is that, especially given that the scoring function uses the median of the submitted scores, i.e. the median of the policies that you have used in the submission file, my guess is that all of those submissions, there had to be some learning, because you can't get lucky that many times. This policy space is pretty large when you consider the resolution of the action and the action space, and you consider the fact that you're making decisions over 5 years. But if you happen to consistently get lucky, then have fun. The question is, can you improve on the policies that you're finding at the beginning? I'd be really curious to see. And one of the pieces of this challenge is that the winners would share or are going to share how they did what they did at the end. So actually at the KDD event. So we look forward to actually learning what worked, what didn't work, understanding what are the things that you'd want to change. Like one of the questions that was really present at the beginning of this challenge when we launched it was, what's the right way to evaluate? We had some thoughts, and we revised those thoughts based on feedback, both from the KDD committee and also you, the participants. And we've centered where we are now because we believe that it's an effective way. But we think that we, as a challenge community, I think we're going to learn from this experience. And in future variants of this challenge, we may explore another approach to evaluate performance. But for now, the rules are fixed. So there's a question, if we can use PyTorch. What do you think, Ali?
Yeah, I will certainly support that. There's no.
Okay. So in that vein, we should develop a list of, so in essence, a requirements.txt that we can put up so that people know what's available in the evaluation and when you get to our world.
Sure. Yeah.
So we'll try to get that up this week, and yes, we will take input, but we can't have everything, guys. We will try to cover the common frameworks so that you don't have to write everything from scratch. But there may be a few obscure libraries or modules that you may have to include with your submission. But I think we should be okay.
Yeah, completely agree. Are there any other questions there? Yeah, with regards to the submission process, I hope it's become clearer. So I've switched the questions now, trying to read them as they come through. So there's an idea behind sharing or uploading scripts, and the fact that everyone can see uploaded scripts at this point. Yeah, certainly at the end of the check phase, for the final submissions, there's not public sharing of the scripts, so the platform won't allow others to see your submission. Perhaps it's something our colleagues at Hexagon-ML can just confirm on the line, maybe if they're able to, or we give them a chance at the end. I can see Uday's on the line, but yeah, there's a concern that currently when you upload a script, you're able to see what people have done within that script file. Of course, yeah, past the check phase, no one will be able to see that publicly.
Uday, are you able to comment on that?
Yes, this is Uday. So past the check phase, we shouldn't be able to see that. Yes, we can map that out.
Okay, cool.
Brilliant. Yeah. So yeah, rest assured that in the submission process of your scripts, they won't be publicly shared. Though, of course, should you come up with good solutions, we, as part of the competition, hope you look forward to presenting them and sharing what was done. And that would be something to think about in terms of your involvement with the competition, if it is difficult for you to share whatever you've developed.
All right, so we still have a few minutes left, and thank you all for joining in very early or very late, wherever you are, or if it's just right, thank you for joining. But if you have any other questions, go ahead and post them. We are trying to keep keep abreast of the forum, and we do know that there are some times that we may not be able to respond like within minutes, but we thank you for your patience. We are trying to juggle our full-time jobs and this adventure into challenge hosting. And we really thank the Hexagon-ML team, because if it wasn't for them, we would not be able to do this challenge. And we're happy that things are going so well. So I think the last time I checked, there were close to 300 teams. Let me see if that, sorry, not 300, close to 200 teams. Let's see what that number looks like today. All right, so we're now 210 teams, 300 competitors, and almost approaching 400 submissions. So people are busy. We're happy about that. The other element is that we are really looking forward to engaging with you at KDD, sharing the experiences that you've had, and also understanding what are the opportunities to improve this experience. So I'm now channeling what I've heard from the organizers of the KDD event. They really want to get more people participating in challenges like these, especially first-time participants. So what does it take to increase the number of people that are willing to give, whether it's reinforcement learning or any other type of machine learning challenge, a chance? So if there are thoughts that you have about that, feel free to drop it in the whether it's a QA or onto the forum. We'd love to hear that.
Hey, Oliver and Seiko. This is Tash, one of the KDD co-chairs. I really would like to thank both of you for hosting this thing, the Q&A sessions, and Hexagon-ML as well. I also would like to see if there are other people who want to write tutorials or want to put that. They are all welcome to put their tutorials as well. I think that's the best way to learn, is by sharing and teaching. So I strongly request everybody to put together tutorials and exchange ideas, and that's the best way. I mean, it's trial and error, as you've seen in both the examples that Seiko and Oliver provided. You're trying to get the best reward and the best policies out. So sharing and keep participating.
Yeah, this is Uday from Hexagon. Definitely thank you for partners at KDD, Tapos, and Arena, and IBM partners. Seiko, Oliver, I think this has been a wonderful partnership. We'd like to see more tractions, more participations, and then more materials. People can learn from each other. And I think any feedback on the platforms, I'd love to hear from the participants as well. So we're constantly improving things. Thank you.
Thanks, Taposh. Thanks, Uday. And yeah, we would just like to echo for anyone on the call or the forum, definitely more open discussion around what seems to work, what might be good approaches. We'd love to facilitate that, and also into the future at the conference as well. Yeah.
All right, so we're approaching the top of the hour. Any last burning questions from our 9 attendees? Or hopefully we've just covered everything so well, you are now ready to go and take over the leaderboard?
It's getting quite competitive at the top, we've observed.
Yeah, I can imagine. The one thing that I wish I had, and maybe we can do this via the forum, if people wanted to share the types of algorithms that they're using as an attribute. So right now, we just, at least the public just knows, hey, this team scored this, but they don't know what kind of methods, unless you've included a name like deep learning in your title of your team name. So in terms of future Q&As, yes, we will continue. We've been doing them about monthly. So that's the time frame, but we will keep answering questions via the forum. or via the Hexagon-ML platform. You can send emails via the platform if there are any pieces. But we generally, I mean, if you would like to send them directly, we try to respond as quickly as possible. But sending them to the forum, you could get the opportunity to have answers from the rest of the competitors or participants, let's say. All right. So I guess then we'll wrap up. See you electronically on the Hexagon platform, Hexagon-ML platform, and I look forward to the next time we all talk.
Thanks, everyone.
Thank you.
Thank you. Thank you.
All right.